right, start streaming. So let's continue. Yeah, I don't need this. So a minimal Rust kernel. All right. Well, I did the first part, which was writing a freestanding binary in Rust. And I kind of, well, that was not too hard, but it was not too hard. Let's go CD code. Well, we're already here. Impros. Impros, just name of the OS, like improvisation OS, Impros. So let's go to source and cat. It would be nice to install sudo xbps install sbat. Let's install bat. So now let's show main. All right, that's bat instead of cat. So don't link the Rust standard library, disable all Rust level entry points, use core panic info, the modules, no mangle, and panic handler. So we have some kind of a start, and then we have, okay, like this. And then we have some kind of a, like panic, what happens when the computer panics. So now the next thing is, yeah, I wouldn't remember these. There are a lot of these, this just comes with practice, you know? But these, okay, a semicolon, but there are these variables, and then this is an divergent, like undefined type, that does not return. And info, arguments, these are the arguments, and which return. This is kind of like Haskell, I guess. Fn, like A goes to B, loop, and it loops. Yeah, it's funny. This is like a type declaration, but it has a loop also. All right, I won't really dig a hole with this one. Okay, in this post, a minimal Rust kernel. All right. February 2018. It's like 5 years, 4 years, 6 years. Okay, so in this post, we create a minimal 64-bit Rust kernel for the x86 architecture. We build upon the freestanding Rust binary from the previous post to create a bootable disk image that prints something to the screen. This blog is openly developed on GitHub. If you have any problems or questions, please open an issue there. You can also leave comments at the bottom. This complete source code for this post can be found in the post 2 branch. Let's look at post 2 branch. Kind of slowish. Wow. Post 2 branch. What's my computer? 6 HTOP. Processor 3 gigs. Yeah, I don't know. Five years ago, 7 months ago, cargo top, don't specify patch version, cargo toml. 9 months ago. So I guess this is a more updated version. Blog OS edition 2018 bootloader 0.9. Patreon, LibrePay, contributors, license. This project requires a nightly version of Rust because it uses some unstable features. At least nightly is required for building. Yeah. Kimu. Do I have Kimu installed? Need to be installed for this. Anyway, I'll check this. All right. Recent conversation. OSDev. Home SL. Twitch. All right, the minimal Rust. So, okay. Table of contents, the boot process. When you turn on a computer, it begins executing firmware code that is stored in motherboard ROM. This code performs a power on self-test. Power on self-test, Wikipedia. Detects available RAM and pre-initializes the CPU and hardware. Afterwards, it looks for a bootable disk and starts booting the operating system kernel. On x86, there are two firmware standards: the basic input-output system. That's the BIOS or the BIOS. I don't know how you read this. And the newer Unified Extension Firmware Interface (UEFI). Yeah, I was always confused about that because I have a BIOS, but when I install Linux, I always use the GPT, which is UEFI, or maybe there could be both. I'm not sure. The BIOS standard is old and outdated, but simple and well supported on any machine since the 1980s. UEFI, in contrast, is more modern and has much more features, but it is more complex to set up, at least in my opinion. Currently, we only provide BIOS support, but support for UEFI is planned too. If you'd like to help us with this, check out the GitHub issue. The GitHub issue. How's my OBS going? Encoding overloaded. It's overloaded again. Why is it overloaded? That's strange. Maybe if I turn down the camera, like resize it, maybe like this. Hi, thanks for this great blog series. Adding UEFI. So are there any writing a text? So this is the latest. I know it's September for annual check-in, but I'm enjoying the series thus far. Could there be a way to easily configure USB I/O if you're using an external machine to display stuff? Like if I ran the OS on a Raspberry Pi and wired it to my laptop to see its logs. Okay. Yeah, this is like a whole... Maybe I'm not up to this. No, I'm up to this. Yeah, no, I'm not up to this, but I'm gonna try, and see. I've probably learned something. Yeah, fail good. BIOS boot. Okay, almost all x86 systems have support for BIOS booting, including newer UEFI based machines that use an emulated BIOS. That is great, because you can use the same boot logic across all machines from the last century, but this wide compatibility is at the same time the biggest disadvantage of BIOS booting, because it means that the CPU is put into a 16-bit compatibility mode called real mode before booting, so that archaic bootloaders from the 1980s would still work. Okay, but let's start from the beginning. When you turn... Yeah, this is a lot of text, don't get me wrong. I appreciate this, but okay, this is just a different approach. I guess for me, what best work is like approach with code, like, but I haven't seen that. This is more like a wish, or maybe I would have to do something like that. Like you write code, a little bits of code, and like the point is when I read something, it's like I'm standing, and when I go into the text editor and kind of just write something, I feel like I'm moving. So not sure if anybody else feels like that. When you turn on a computer, it loads the BIOS from some special flash memory located on the motherboard. The BIOS runs self-test and initialization routines of the hardware. Then it looks for bootable disk. If it finds one, control is transferred to its bootloader, which is a 512-byte portion of executable code stored at the disk's beginning. Most bootloaders are larger than 512 bytes, so bootloaders are commonly split into a small first stage, which fits into 512 bytes, and a second stage, which is subsequently loaded by the first stage. The bootloader has to determine the location of the kernel image on the disk and load it into memory. It also needs to switch the CPU from the 16-bit real mode into the 32-bit protected mode and then to 64-bit long mode. Its third job is to query certain information memory map from the BIOS and pass it into OS kernel. Writing a bootloader is a bit cumbersome as it requires assembly language and a lot of non-insightful steps like write this magic value to this processor register. Therefore, we don't cover bootloader creation in this post and instead provide a tool named boot image that automatically prepends a bootloader to your kernel. Oh. So, boot image. Oh, come on. Encoding overloaded or using a faster encoding preset. Yeah. Boot image also from him. Creates a bootable disk image from a Rust OS. If you're interested in building your own bootloader, stay tuned. The set of posts on this topic is already planned. The multi-boot standard. To avoid that every operating system implements its own bootloader, which is only compatible with a single OS, the Free Software Foundation created an open bootloader standard called Multi-Boot 1995. The standard defines an interface between the bootloader and the operating system, so that any multi-boot compliant bootloader can load any multi-boot compliant operating system. The reference implementation is GNU Grub, which is the most popular bootloader for Linux systems. Oh, Grub is from GNU. I didn't know that. I kind of really never looked into Grub. I know Grub for so many years, but it's always like hi, that's it. Multi-boot, nice. To make a kernel multi-boot compliant, one just needs to insert a so-called multi-boot header at the beginning of the kernel file. This makes it very easy to boot on OS from Grub. However, Grub and the multi-boot standard have some problems too. Again, a lot of text. They support only the 32-bit protected mode, 64-bit. They're designed to make the bootload simple instead of a kernel. Kernel needs to be linked because group can find boot information, are only sparsely documented. Grub needs to be installed. We decided to not use Grub or the multi-boot standard. However, we plan to add multi-boot support to our boot image tool so that it's possible to load your kernel on a Grub system too. If you're interested in writing a multi-boot compliant kernel, check out the first edition of this blog series. We don't provide UEFI support at the moment, but we would love to. If you'd like to help, please. Okay, a minimal kernel. Now that we roughly know how our computer boots, it's time to create our minimal kernel. Our goal is to create a disk image that prints a hello world to the screen when booted. We do this by extending the previous post's freestanding Rust binary. As you may remember, we built the freestanding binary through Cargo, but depending on the operating system, we needed different entry point names and compile flags. That's because Cargo builds for the host system by default, the system you're running on. This isn't something we want for our kernel because a kernel that runs on top of Windows does not make much sense. Instead, we want to compile for a clearly defined target system. Why Rust? Maybe I don't have to in Rust. Rust has 3 release channels, stable, beta, and idly. The Rust book explains the difference. For building an operating system, we will need some experimental features that are only available on the nightly channel, so we need to install a nightly version of Rust. To manage Rust installations, I highly recommend RustUp. With RustUp, you can use a nightly compiler for the current directory by running RustUp override set nightly. Alternatively, you can add a file called Rust toolchain with the content nightly to the project's root directory. You can check that you have a nightly version installed by running rustc version. The version number should contain nightly at the end. The nightly compiler allows us to opt in to various experimental features by using so-called feature flags at the top of our file. For example, we could enable the experimental assembler macro for inline assembly to the top of our main RS. Note that such experimental features are completely unstable, which means that the future Rust versions might change or remove them without prior warning. For this reason, we will only use them if absolutely necessary. Yeah, so what's this? Like clockwork. All right. Like clockwork. Yeah, I guess it gets overloaded when I'm on Twitch. Yeah. Overloaded. Maybe if I turn off like this, will this thing still remain? Yeah. All right. I'm curious, like, are these things available in the standard Rust? He's just curious, why is my computer kind of slowish? Better. So are these versions, are these experimental from 2.18 available now? It has been reworked as ISML and later global ISML macros in the more controlled version. ISML was stabilized in Rust 1.59. Okay. So target specification. Cargo supports different target systems through the target parameter. The target is described by a so-called target triple, which describes the CPU architecture, the vendor, the operating system, and the ABI. For example, the x86-64 unknown Linux GNU target triple describes a system with an x86-64 CPU, no clear vendor, and a Linux operating system with the GNU ABI. Rust supports many different target triples, including ARM Linux. Requires some special configuration parameters, no underlying OS. Rust allows us to define our own target through a JSON file. A JSON file that describes the X looks like this. More stack pre-link args, linker flavor, target, pointer width, target endian. All right. Most fields are required by LLVM to generate code for that platform. For example, the data layout field defines the size of various integer, floating point, and pointer types. Then there are fields that Rust uses for conditional compilation, such as target pointer widths. The third kind of field defines how the crate should be built. For example, the pre-link args field specifies arguments passed to the linker. We also target x86-64 systems with our kernel, so our target specification will look very similar to the one above. Let's start by creating an x86-64 blogos JSON file. Choose any name you like with the common content. So let's start by creating an OS. Choose any name you like with the common content. Now that we changed the OS in the LLM target and the OS field to none, because we will run on bare metal, we add the following build related entries. Instead of using the platform's default linker, we use the cross-platform LLD linker that's shipped with Rust for linking our kernel. So where do I JSON file? So I'm in, okay, wait, I'll remove this. Okay. x86 64 my cats. '64. Improv os. Imper os. Imper os. Impros JSON. All right. Oh, okay, I'll just copy this. I won't really. So we have LLVM target data layout. What's this data layout? From where does this come from? Oh, Arch. I see 32, 64, 128. This is probably some kind of, not sure what's the right word, but like what kind of integers can it take, or what? Wait, what's the data layout line? What's the data? The data layout line is your target specification file, how data is arranged, yeah. In memory for the target architecture, this is crucial in low-level programming. OS development, how different types are stored. Yeah, different types of numbers. Different types are stored in access. EME specifies little endian. The least significant byte is stored at the smallest address. ME refers to the mangling scheme used by LLVM. And this, pointer widths and alignment, how pointers to specific memory segments are handled. P70 means that pointers with the ID are 32 bits wide. Repeated 64 have 64-bit alignment. Yeah. Preferred stack alignment for this target. S128 means the stack should be aligned to 128 bits. This is so technical. Yeah, this is very low level. Like, who would know? Why would... like, how would I write this? I have to get this from somewhere. I can't put this on my mind. I'm curious, like, how do you write an operating system in Haskell? Like, probably you have to do this too, right? Is there something like this? Write your own operating system, boot and multi-boot. Operating system basics, hardware basic, Unix system calls. Yeah, this is a series I found, and he's also First edition. He's referencing it too, but he's writing it in C. Yeah. All right. Note that we changed the OS in the LLVM target. None. Yes, now it's none. And the OS field to none because we will run on bare metal. We add the following build related entries. Linker flavor LDD. We add the following build related entries. Wait, let me check the where's the main? No. The complete source for this post. Yeah. Is it this one? Oh yeah. Okay. Where's the JSON file? That's okay. Very slow, this computer now. Let's see if I'm having problems. Maybe my encoding is, I don't know. Should change something about the encoding. Higher encoding or a bit. Can I change encoding while being in a stream? Can I change encoding, OBS while in the stream? No, you can change. All right, stop the stream. Okay, I won't stop the stream. I won't stop the stream. Ah, this is it. 9 months ago. All right. LLVM target. So what do we got? Right, Arch. Target Endian. Little 6432. Non-OS none. Executables true. And then, okay, then below that, a minimal Rust. Wait, just lost it. Below that, we add the linker flavor LDD. Well, let's type. Come on, because we should type something, because then we are like real programmers. Linker flavor. Why is this red? Linker flavor LD LLD. Why is this red? Because it didn't put a comma? Linker flavor. Linker. Rust. LLD. Yeah, why is this red? Linker flavor. try it again. Why is it red? Oh, I have no comma. I have no comma here. Ah. So instead of using the platform's default linker, which might not support Linux targets, we use the cross-platform LLD linker that is shipped with Rust for linking our kernel. Panic strategy abort. This setting specifies that the target doesn't support stack unwinding on panic, so instead the program should abort directly. This has the same effect as the panic abort option in our cargo toml, so we can remove it from there. Note that in contrast to the cargo toml option, this target option also applies when we recompile the core library later in this post. So even if you prefer to keep the cargo toml option, make sure to include this option. Okay. Panic strategy abort. Panic strategy abort. So this setting specifies that the target doesn't support. Okay. Disable red zone. True. Disable red zone. Like all these code names. True. Give me math. We are writing a kernel, so we need to handle interrupts at some point. To do that safely, we have to disable a certain stack pointer optimization called the red zone, because it would cause stack corruption otherwise. For more information, see our separate post about disabling the red zone. Are we going to look into that? Maybe not. Maybe just take a peek. Disable the red zone. System 5 ABI. Oh, interesting. The image shows the stack frame of a function with n local variables. On function entry, the stack pointer is adjusted to make room on the stack for the return address and the local variables. The red zone is defined as the 128 bytes below the adjusted stack pointer. The function can use this area for temporary data that's not needed across function calls. Thus, the two instructions for adjusting the stack pointer can be avoided in some cases. Wow. That take weeks to debug. Horrible. Horrible. We are writing a kernel, so we need to handle interrupts at some point. All right. Features MMX, SSE, soft float. Okay, I'm just going to copy this because there are a lot of, I might write a mistake. All right, features MMX, SSE, soft float. The features field disables target features. We disable the MMX, so you disable with a minus, okay. And SSE features by prefixing them with a minus, and enable the soft float feature by prefixing it with a plus. Note that there must be no spaces between different flags, otherwise LLVM fails to interpret the feature string. The MMX and the SSE features determine support for single instruction multiple data instructions, which can often speed up programs significantly. However, using the large SIMD registers in OS kernels leads to performance problems. The reason is that the kernel needs to restore all registers to their original state before continuing an interrupted program. This means that the kernel has to save the complete SIMD state to main memory on each system call or hardware interrupt, since the SIMD state is very large and interrupts can occur very often. These additional save restore operations. Wow, this is hard. You know, the thing is, it's like it would be nice. Now I'm again a rant. Like building an operating system is like playing chess or Go or something. Like simple rules, but then you can increase the complexity. on your own. But here you have to know a lot. Even functional programming, it has a lot of info, but these are very, it's not so abstract. It's very external. Like I learn about the functions, but now there are each function has a story of its own. Where it's from, what it does, what it is, what it is, and then you have to like remember all that. So to become really good at this, you have to do this for many years, and then you become good at it, which kind of it's not so fun. Of course, it's fun, but it's like you need. Yeah. Anyway, I'll stop. A problem with disabling SIMD is that floating point operations on x86-64 require SIMD registers. By default, to solve this problem, we add the soft float feature, which emulates all floating point operations through software functions based on normal integers. For more information, see our post on disabling SIMD. Putting it together, okay. Our target specification file now looks like this. Features. Target C int with. I think it's the same. Yeah. Building our kernel. All right. So compiling for our new target will use Linux conventions. Yeah, I think the encoding kind of starts up when yeah. Compiling for our new target will use Linux conventions since the LD-LDD linker flavor instructs LLVM to compile with the flavor GNU flag. For more linker options, see the Rust C documentation. This means that we need an entry point named start as described in the previous post. Source main RS. All right. Oh. Someone is not feeling too well in the apartment next door. Or it's just... Oh, that's the bathroom. I can hear the bathroom. Oh, yeah. Okay. Note that the entry point needs to be called start, regardless of your host OS. This royalty-free is not really royalty-free streaming. I want to change. Maybe this. Note that the entry point needs to be called start regardless of your OS. This is slightly different, right? Should we have a comma? Sometimes this thing, maybe we should not have a comma at the end. No, we should not, yeah. So source main RS, no std, no main, use core panic info, right? And this function is called on panic handler, right? This function is called, why there's, this function is called on panic. Okay, don't mangle the name of this loop, panic. All right. This function is called on panic. No, no, it's different. Wait, did things change? This function is called on panic. The mangle. Oh, I have to move the mangle. How do I move it? Yeah, this. And yank. Delete. And paste. All right. Ah, this function is called on panic. Right. Don't mangle the name of this function. Pub extern C fn start. This function is the entry point since the linker looks for a function named start by default. Pub extern C fn start. This function is the entry point. This function is the entry point since the linker looks for a function named start by default. Is this like the documentation? Like 3 slashes by default? Maybe it is. Like what's the meaning of 2 or 3 slashes in Rust code? 2 or 3 slashes are used for comments, but they have different meanings. Maybe for document line comment. Anything after, okay, this is a line comment. Documentation, outer documentation, yeah, which generates API documentation for the item that follows. Okay, add 2 numbers together, examples. Module level documentation, inner doc. Oh, inner doc, module level documentation. Summary, regular comment, ignored by compiler. Generates documentation for the following item. Documents the enclosing module or crate. All right. Note that the entry point needs to be called start regardless of your host OS. We can now build kernel for our new target by passing the name of the JSON file as target. All right, we can now build a kernel. So now we're going to do cargo build. All right. Do we go, or can we state in the source? Yeah, all right. Cargo build target. No. Where's my ls? Ah, it's here. Cargo build target x 86. Why doesn't it JSON? Can't find crate for core. Target may not be installed. Consider downloading the target with Rust up target. For more information about this error, try Rust up explain could not compile impros bin impros due to one previous error. All right. What's that timer app I installed? I just need to quickly. timer. No, it was like Linux one. I installed something. Time. Turn down. Can find crate for core. It fails. The error tells us that the Rust compiler no longer finds the core library. This library contains basic Rust types such as result, option, and iterators, and is implicitly linked to all no-std crates. The problem is that the core library is distributed It's Alka Crab, game music. This library contains basic Rust types such as result, option, and iterators, and is implicitly linked to all no-std crates. The problem is that the core library is distributed together with the Rust compiler as a pre-compiled library, so it is only valid for supported host triples, but not for our custom target. If we want to compile code for other targets, we need to recompile core for these targets. First, the build std option. That's where the build std feature of Cargo comes in. It allows to recompile core and other standard library crates on demand instead of using the pre-compiled versions shipped with the Rust installation. Oh, this feature is very new and still not finished, so it's marked as unstable. Maybe it's already available. To use the feature, we need to create a local cargo configuration with the following content. Let's check because this was updated. Cargo config toml of 4 years ago. Unstable. Is this still unstable? It's still considered unstable. Okay. So in cargo config toml, cargo. So where's the cargo config? It's funny, I don't have it. No, cargo, it's here. And didn't I already write something config? Config toml. So unstable. Unstable. Build std. Std. Core. Well, that really is. Core. And compiler built-ins. Compiler built-ins. So this tells Cargo that it should recompile the core and compiler built-ins libraries. The latter is required because it is a dependency of core. In order to recompile these libraries, Cargo needs access to the Rust source code, which we can install with rustup component, add rustc. Rust source. Ah, so I do have to install Rust nightly. Yeah. Do I need Rust nightly for this? Nightly for unstable. Use rustup to install Rust nightly alongside stable. Okay. Rustup install nightly. Clippy. Rustup, you can set the nightly toolchain as the default for your project directory. Rustup override set nightly. This makes Rust nightly the default for that specific project without affecting your global Rust setup. But where do I run this code? Because I see no name of my project mentioned. My project directory is called imper.oz. Yeah, do I go to the directory? Navigate to the improz. Okay. So we're gonna go to CD. Let's step out of improz. No, CD code. No, we go to improz. CD improz. No, we go to improz. I don't know. Will this be a problem? I accidentally, yeah. I accidentally, when making a project directory with cargo, made a directory within a directory. So my impros has a parent impros directory. I guess I can rename the parent one without affecting the impros, which has git enabled. Yeah, I could name it Rust. Yeah, I can rename the parent without affecting the inner impros new parent name. This will only change the outer folder name. Okay. So let's move out impros. So if I move out code, so let's mv impros and let's call it rustos. Rustus. Well, let's just call it Rust. Let's go to Rust and impros. All right, this is better because that was confusing. Okay, so the unstable. Did I add the unstable? I have to add the unstable. So I go to, I'm in impros, all right. Rust up override set nightly. All right, that was set. After setting, did I write this? Cargo config toml? I did. I think I did. Maybe bat config. No, it's cargo config toml. Yeah. All right. Code rust impros. After setting the unstable build std configuration key and installing the Rust, I didn't install the Rust code. Rust up component. Rust up component. Add Rust source. Is it like this? Downloading Rust source. That was quick. So the unstable build std configuration key, right? After setting the unstable build configuration key and installing the Rust source component, we can rerun our build command. So when we rerun, what was it? Come on. You should search for. Maybe there's a way to search. All right, this. All right. Building. Let's make a print screen. Wait. It's still building. Unoptimized debugging. It doesn't catch the camera. Oh, interesting. All right. After setting the unstable build std configuration key and installing the Rust RC component, finished optimized. All right. We see that cargo build now recompiles the core Rust-C std workspace core dependency of compiler built-ins and compiler built-ins libraries for our custom target memory related intro. It's a lot of text. The Rust compiler assumes that a certain set of built-in functions is available for all systems. Most of these functions are provided by the compiler built-ins crate that we just recompiled. However, there are some memory related functions in that crate that are not enabled by default. Because they are normally provided by the C library on the system, these functions include memset, which sets all bytes in a memory block to a given value, memcpy, which copies one memory block to another, and memcmp, which compares two memory blocks. While we didn't need any of these functions to compile our kernel right now, they will be required as soon as we add some more code when copying structs around. Since we can't link to the C library of the operating system, we need an alternative way to provide these functions to the compiler. One possible approach for this could be to implement our own memset functions and apply the no-mangle attribute to them. To avoid the automatic renaming during compilation. However, this is dangerous since the slightest mistake in the implementation of these functions could lead to undefined behavior. For example, implementing memcopy with a for loop may result in an infinite recursion because for loops implicitly call the into iterator. Yeah, I still don't like loops. Trait method, which may call memcopy again, so it's a good idea to reuse existing well-tested implementations instead. Fortunately, the compiler built-ins crate already contains implementations for all the needed functions. They are just disabled by default. To not collide with the implementations from the C library, we can enable them by setting cargo's build std features flag to compiler built-ins mem. Like the build std flag, this flag can be either passed on the command line as the -z flag or configured in the unstable table in the cargo config toml. Since we want to build with this flag, the config file option makes more sense to us. Yeah, it's a lot of text. For me, it's just a lot. Build std features. Bisetting flag. Well, these flags, it's very imperative. Like, why? Okay, unstable build std features, build std core compiler built-ins. Okay. hx, let's go like this. Cargo config toml build. So oh, I could have done, wait. So I could write capital O. Yeah, all right. Build std features. Compiler built-ins mem. Yeah, I don't know why are we using this. Support for the compiler built-ins mem feature was only added very recently, so you need at least Rust nightly. Behind the scenes, this flag enables the mem feature of the compiler built-ins crate. The effect of this is that the no-mangle attribute is applied to memcopy implementations of the crate, which makes them available to the linker. With this change, our kernel has valid implementations for all compiler required functions, so it will continue to compile even if our code gets more complex. Set a default target. To avoid passing the target parameter on every invocation of cargo build, we can override the default target. To do this, we add the following to our cargo configuration file at cargo config toml. Set a default target. We add the following to our cargo configuration file at cargo config toml. Cargo config toml. So we add the build also. Build std build. Where am I going to put it? Build target. Okay, x86 64. Now I'm at that phase where it's becoming not tiring, but not so much fun. It's fun, but not so much. It's a lot of words. I appreciate the explanations, but maybe it's really hard, yeah, to make something like playful. How do you make building an operating system playful? Imper Oz JSON. All right. This tells cargo to use our where no explicit target. This means that we can now build a kernel with a simple cargo build. Check out official documentation. We are now able to build our kernel for a bare metal target, simple cargo build. However, our start entry point, which will be called by the bootloader, is still empty. It's time that we output something to screen from it. Wow, print. The easiest way to print text to screen at this stage is the VGA text buffer. It is a special memory area mapped to the VGA hardware that contains the contents displayed on screen. It normally consists of 25 lines that each contain 80 character cells. Each character cell displays an ASCII character with some foreground and background colors. We will discuss the exact layout of the VGA buffer in the next post, where we write a first small driver for it. Cool. For printing hello world, we just need to know that the buffer is... So we are writing a hello world. The hello world of the operating systems. That's kind of cool, right? Because I always remember, print hello world and that's it. Sometimes you have to write a bit more, like in C, like void main, or I don't know, or Python. But this is a hello world. Look at this. We just need to know that the buffer is located at address and that each character cell contains an ASCII byte and a color byte. We'll just put... All right. Static hello. No mangle. What's this now? Is that our main RS main source file? Static hello, hello world, no mangle. Static hello, hello world, no mangle. Pub extern C, yes. So let's compare this with our so let's go to source. Where's the no mangle? Don't mangle the name. Pub extern C. Yeah, that's our function. Static hello. Where do we write the static hello? Above it? Static hello. Hello. Static hello colon. And now ampersand U8. Some kind of a space of a type U8, unsigned char or something. B, YB, hello world. Hello world. Static hello. So now we have the no mangle. And now we're gonna pub extern. We have pub extern C, function start, and it's divergent. Okay, now we go into the body of the function. We're gonna delete this. We're gonna delete this and we go let, so we need to write VGA buffer. And I'm not sure what's this number, some kind of a size thing. XB 8000. As you can see, you see all of these kind of codes. I never liked this, you know, when I was trying to learn programming, and this somehow made, and then when I heard Bartosz Milewski, who talks a lot on functional programming, he was saying, you know, like humans are not meant for this. For I and then ampersand byte and hello iter enumerate unsafe. So maybe we delete, oh, we don't delete the loop, right? So unsafe. Yeah, but how will I even repeat this? Unsafe. Okay, unsafe. So we have a VG buffer. No. VGA buffer. I guess that's the variable offset. I as I size. You see, this is so imperative. I size byte, and then VGA again. Offset, I guess. Yeah, I as I size, also times 2, but plus 1. And 0xb. So I just wrote this. Yeah, I'm a programmer. First, we cast the integer 0xb 0xb into a raw pointer. Was this some kind of magic? We cast the integer into a raw pointer. Where is that? Oh, this. Let VGA buffer as mut rust raw pointer. I don't even know what's a raw pointer. Unsafe rust. Dereferencing a raw pointer. In chapter 5, dangling references, we mentioned that the compiler ensures references are always valid. Unsafe rust has two new types called raw pointers that are similar to references. Raw pointers can be immutable or mutable and are written as const t and mut t. All right, what do we have? Mut u8. Different from references and smart pointers, raw pointers are allowed to ignore the borrowing rules by having both immutable and mutable pointers, or multiple mutable pointers to the same location. Aren't guaranteed to point to valid memory, are allowed to be null. Don't implement any automatic cleanup by opting out. Yeah, these are some Rust programming language. Unsafe, FN dangerous. Creating a safe abstraction over unsafe code. All right. So first we cast this into a raw pointer, whatever that means. Then we iterate over the bytes of the static hello byte string. We use the enumerate method to additionally get a running variable I. In the body of the for loop, we use the offset method to write the string byte and the corresponding color byte. Note that there's an unsafe block around all memory writes. The reason is that the Rust compiler can't prove that the raw pointers we create are valid. They could point anywhere and lead to data corruption by putting them into an unsafe block. We're basically telling the compiler that we are absolutely sure that the operations are valid. Note that an unsafe block does not turn off Rust safety checks. It only allows you to do 5 additional things. The unsafe superpowers. I want to emphasize that this is not the way we want to do things in Rust. It's very easy to mess up when working with raw pointers inside unsafe blocks. We could easily rewrite beyond the buffer's end if we are not careful. So we want to minimize the use of unsafe as much as possible. Rust gives us the ability to do this by creating safe abstractions. For example, we could create a VGA buffer. Okay, can you explain to me this like I'm 4? Maybe it will work like this. Okay. ChatGPT, it's your turn. Okay, explain me this like I'm 4. All right, imagine you have a big drawing board where you can write messages for everyone to see. But this board is very special. Each space, oh, this is like me saying to my son, but this board, sometimes I ask ChatGPT to generate for me, and it's a really great way to use. I started to do this actually recently. I would, you have to come up with some kind of bedtime story. And with ChatGPT, I can ask him, generate like a bedtime story for me that has this, this, and that goes this, this, and there, that actually has a couple of F words. F words, not those F words. He was practicing the F sound. So maybe that the story, F word. So the story has like some words that start with the letter F. And yeah, and it can really, and maybe he will like the story about dragons and, him. And then I said, like, make a compassionate story, or a story where there was an argument if he had one that day, and then the ChatGPT makes up in kind of an argument and how they all make peace. So anyway, all right, imagine you have a big drawing board where you can write messages for everyone to see. But this board is very special. Each space on the board has room for one letter and a color. Well, maybe I could do this with my son. Imagine you have a big drawing board where you can write messages for everyone to see, but this board is very special. Each space on the board has room for one letter and a color. This would be cool, really. We have a pen here. Where's the... So, all right, imagine you have a big drawing board where you can write messages for everyone to see. But is it like a checkerboard? But this board is very special. Each space on the board has room for one letter and a color. Let's say I have a board. And, well, I'll just draw like a checkerboard, you know, like this. Now, let's say we want to write hello world on this board, but instead of using a pen, we have to tell our board exactly where to place each letter and what color to use. And here's the catch. We're using the board that lives inside our computer screen, not a real physical one. Oh, this is so cool. Maybe I can make a computer. I was wondering how to start programming with my son, who's 4. Maybe we could do it like this. We're using the board that lives inside our computer screen, not a real physical one. Okay? Finding the board. In this case, our board starts at a special place in the computer's memory called 0xb800, 8000. Think of this like an address on the board where we can start writing. We are telling the computer to look at that exact spot to start drawing our message. So I just have a checkerboard with 1, 2, 3, with 9 squares. We're telling the computer to look at that exact spot to start drawing our message. Letters and colors. For each spot on the board, we need 2 things. A letter, okay, 2 things. For each spot. We need a letter like H or E, okay? We need slovo, or like a letter, and color, boya, like blue or green. In this example, 0xb means a light cyan color. Each letter and color are stored together in pairs, like a box with a label and its color. So it's like a pair. Each letter and color are stored together. Svako slovo I boja. Each letter and a color are stored together in pairs. Svako slovo I boja su par. Are stored together. Su skupa. U paru. Like a box with a label and its color. Kao kutija. Okay, kao kutija sa etiketom. I bojom. So writing the message, we have our message hello world saved in a list called hello. Saved in a list called hello. A imamo listu koja se zove hello. The code goes through each letter in Hello World and places it on the board at the right spot. It also pairs each letter with the color cyan so it shows up in light blue. Safety. Normally Rust, the programming language we're using, is very careful and doesn't want us to accidentally write in the wrong place on the board, which could mess things up. But here we're telling Rust, don't worry, we know exactly where we are writing and safe. This is called using an unsafe block. It's like asking permission to draw on a very special area carefully. Making it safer. This approach is a bit tricky because if we make a mistake, we could easily draw outside the board, which could break things. So in the future, we'll create a helper, like a special crayon that only lets us color in the lines, which will make sure we stay safe and only draw where we are supposed to. So this looks like a great game that I could introduce to my 4-year-old. I'm not sure, or can you arrange it? So, like, what happens with the list hello? I have a board with, let's say, 9 squares, so 3 times 3, and color and a letter that goes in a pair. Now make me such a game where my son could write a word such as hello world, or using these rules. Here's a simple version of a game inspired by what you described. It uses a small board and lets your son combine letters and colors to create words. Since hello world won't quite fit on a 3 times 3, we can start with the shorter words like hello, or even single letters to get used to the idea. Game setup. Board. A 3 times 3 grid with 9 squares. You can use paper or make a small board with actual squares drawn on it. Letters and colors. Have a set of cards or tiles. Each one has either a letter, okay, I'll make cards with hello, a color, like a colored background, or border on the card. How do I do the colors? Maybe I can make small letters and then the letter goes on a letter. I need letters. I need letters. Do we have letters? We have letters. Okay. A color, all right? A color like a colored background or border on the card. So rules. Choose a word. Start by picking a simple word that fits on the board, like hello or cat. Now place card on the board. Which card? Each square on the board can have one letter and one color. For each letter in the word, place a matching letter tile on the board. For each letter in the word, place a matching letter tile on the board. But then pair each letter with a color by placing a color tile on top or next to the letter card. Create the word. Encourage your son to arrange the letters in order on the board to spell out the word you choose. He can choose colors for each letter as he goes. Let's say you're working with the word hello. All right. So place each letter on the board, left to right, one square at a time. Hell, H-E-L in the first row, then L-O in the second. Step 2, let him pick colors for each letter. H could be blue, E could be red, etc. Step 3, when the word is completed, celebrate his arrangement. Then try mixing up letters and colors to form new words or practice different patterns. This setup helps teach the concept of associating positions with specific information and creating patterns based on coding rules. You could even add more letters and colors for later for bigger boards and words. But what's the connection? What's the programming connection with colors, and like by what logic does he pick a color? The idea of pairing letters and colors can connect to programming concept by creating rules or conditions. Pattern matching. In programming, we often use rules to decide what happens next. Rule 1. If a letter is a vowel like a, e, I, o, u, he could choose a bright color like yellow or blue. If a letter is a consonant, he might pick a darker color like red or green. Maybe that's too much for him. Maybe I could put rules. Okay, I could put rules. This introduces I could make groups. So if the word hello, let's say a word hello. So a word hello has an E and has an O. And this is bright. And then we have H, L, and L. And this is dark. What are bright colors for him? Maybe he will not know. But I can group them, and he must pick a color. So it maybe is too much for him, but if he can pick a color. Position-based colors. Another rule could be based on the position. So this introduces the idea of pattern matching. So this is actually pattern matching. Position-based colors. Another rule could be based on the position of the letter in the word of the board. Position of the letter in the word of the board. Rule 3. For example, the first letter could always be green. The middle letter could be red. And the last letter blue. This introduces a simple form of logic based on position, similar to arrays in programming, where items have specific spots. This is so nice. Wait, let me make some notes. I didn't log in. So NixOS, yeah. So programming games. So this will be a this thing. Position-based colors, letter color key. You could even let him create his own color key, like a mini program. For each letter, he picks a color that will always go with that letter. Like H is blue, E is yellow. Then he sticks to that rule when placing letters on the board. This is similar to creating variables or constants in programming, where each value has a defined property. Conditional choices. As a fun twist, add conditions for specific colors. Rule 4. If he wants to use his favorite color, he has to find a way to code it in. He can only use his favorite color on a letter in the first row. This includes a form of if-else conditions where one outcome happens if a rule is true. Wow, this is so amazing. Wow, I'm so happy. So wait, the game is... Wow, I'm so happy that started to do this. I was first complaining about Rust. I mean, I was complaining about this kind of code that is imperative. And now I'm emotional because I can make a game for my son. I can make a game for my son. This is so nice. This is so nice. I think mommy will like this. And they really like this theme. This color scheme. Wow, I'm so happy about this. What a nice yeah. Oh, that's so beautiful. What's the time? 1:36. All right. Let's continue with this. So this is what we're doing actually, right? So basically, so this is what, so wait, I'll go back to this. So this code does? Can you explain it now a bit more high level? Wow. Yeah, that's exactly right. At a higher level, this code uses similar principles of pattern matching logic and structure to control where and how each letter and color appear on the screen. Defining the message. Data is code. The code starts by defining the message "Hello World" as a sequence of letters and bytes. This is like how you and your son define what word to put on the board. Thank you, ChatGPT. I'm emotional now. Here the code uses hello, a list of bytes, to store each letter in Hello World so it can process each one individually. Accessing the board, memory mapping. So the code knows that it has to write to a specific place in memory, address, which is like saying we start writing letters on top of left square. In programming, memory locations hold data like letters, numbers, or colors. And 0xb 8000 is a special address reserved for displaying text on a VGA screen. In our analogy, this is the board where the letters and colors will appear. Assigning letters and colors. The code then loops through each letter in Hello World and places it on the screen. The code loops through each letter in Hello World and places it on the screen. Pattern application. For each letter, it places the letter itself and then a color value. 0xb, representing light cyan. The color choice here is fixed, always 0xb, but you could imagine adding rules to change it dynamically based on different letters. Positioning each letter, rules of placement. Each letter is placed at a different position on the board. The code does this by moving along the memory address for each new character, calculated by multiplying the index by 2. Oh, this is the movement. The offset means, but would be cool to like write this, right? To write this as a game, like a terminal game for my son. A simple terminal game could mimic the letter color board concept, where he can enter letters and pick colors that appear on the grid in the terminal. Game setup, grid display, letter and color input, game flow. Choose a cell. He picks a cell like top left middle, which you could number from 1 to 9. Select a letter and color. After choosing a cell, he enters a letter. Then he picks a color using numbers for each selection. Display update. The grid updates with the chosen letter and color implementation outline. This is in Python. Wow. Yeah, let's we could do this in Rust as some kind of a, because I don't know Rust. Maybe I could do this in Rust. All right, let's get back to this unsafe right loop. So first, did I write this? Yeah. So first we cast the integer into a raw pointer. Then we iterate over the bytes of the static hello byte string. We use the enumerate method to additionally get a running variable I. In the body of the for loop, we use the offset method to write the string byte and the corresponding color byte. That's the string byte and the color byte. Note that there's an unsafe block around all memory writes. The reason is as the Rust compiler can prove, okay? Yeah, running our kernel. Now that we have an executable that does something perceptible, it's time to run it. First, we need to turn our compiled kernel into a bootable disk image by linking it with a bootloader. Then we can run the disk image in the QEMU virtual machine or boot it on real hardware using a USB stick. Be nice because then he could pick the letters. Yeah, running our kernel in the QEMU virtual machine. Do I have QEMU? I don't think I have QEMU. Sudo x what's going on? Sudo x bps install. Let's do first query rs QEMU. QEMU. Can just do open source. QEMU. Okay. No, it's not like this. It does work like this. Wait. Oh, really? XVP install QEMU. All right, I'll download this. How long am I doing this? 1:43 minutes. Running our kernel. Now that we have an executable that does something perceptible, it's time to run it. First, we need to turn our compiled kernel into a bootable disk image by linking it with a bootloader. Then we can run the disk image in the QEMU virtual machine or boot it on real hardware using a USB stick. Creating a boot image. To turn our compiled kernel into, is it compiled? When did he compile it? Yeah, maybe it's better to make the game for my son with hands. So I make a board and then he picks colors and letters. And maybe I could make a box right from which he can pick the colors. Do I? I'm not sure. Sudo cargo build. Can't find crate for core. Cargo build. And what if we now go to source and we do cargo build? unused config. Target path is not a valid file. Really? No such file or directory. Now that we have an executable that does something perceptible, it's time to run it. First, we need to turn our compiled kernel into a bootable disk image by linking it with a bootloader. Then we can run the disk image in the QEMU virtual machine or boot it on real hardware using a USB stick. Creating a boot image. To turn our compiled kernel into a bootable disk image, we need to link it with a bootloader. As we learned in the section about booting, the bootloader is responsible for initializing the CPU and loading our kernel. Instead of writing our own bootloader, yes, which is a project on its own, we use the bootloader crate. This crate implements a basic BIOS bootloader without any C dependencies, just Rust and inline assembly. To use it for booting our kernel, we need to add a dependency on it. So in cargo toml, which is at cargo I think, cargo tom, no, it's here, cargo toml. Addition. It's not addition 220. Why did he write 221? Maybe that's the Rust edition. Oh. Dependencies. Here, dependencies. Bootloader. 0.9. No, this post is only compatible with bootloader 0.9. Newer versions use a different build system and will result in build errors when following this post. Adding the bootloader as a dependency is not enough to actually create a bootable disk image. The problem is that we need to link our kernel with the bootloader after compilation, but Cargo has no support for post-build scripts. To solve this problem, we created a tool named bootimage that first compiles the kernel and bootloader and then links them together to create a bootable disk image. To install the tool, go into your home directory or any directory outside of your Cargo project and execute the following command in your terminal. So go into your home. Cargo install boot image. Yeah, first problem. Cargo install boot image. No such file. Yeah, not sure if ChatGPT will be able to help with this. But cannot find it. Home Domago. Oh wait, where did I put it? Cargo target. But why is it looking for it in home Domago cargo? Target path. Let's check out. This is bad X. Yeah, I'm not sure. What do I do now? Home Domagoj. Do I have to put it? Is not a valid, but can't find it? No, I don't think so, right? Let's copy X. Home Domagoj. X86. 64 and pros JSON. Let's try again this. CD cargo install bootloader. Now it's working. Fail to parse. Cargo toml caused by the cargo feature profile rust flags require a nightly version of cargo. This is the stable channel. But I thought I did install Rust nightly, but now I get this. Both Rust and Cargo are using the nightly versions, as the bootloader requires the nightly Cargo feature profile Rust flags. Switch to nightly Cargo. Rust up default nightly. Navigate to the project directory. And do rust up override. Didn't I do this? So if I do now again, no. It still says that cargo version. Cargo should display a nightly version such as nightly. It doesn't. It still doesn't. Confirm nightly cargo activation. Stop! This is incredible with ChatGPT with this. Run rust up show. Active toolchain, install toolchain, nightly, active toolchain, stable, rust C. Yeah, I'm not sure what I'm seeing. You should see nightly listed under the default host or the active toolchain. Well, I don't see it. What's going on? I think I don't see it. Set nightly as the default toolchain for all your Rust projects. After this, running rust up show should show nightly. Rust up default nightly. Running rust up show should show nightly as the active toolchain. Nightly. Set nightly for a specific directive. Verify. Retry the cargo install bootloader. Unused config. There is nothing to install in bootloader because it has no binaries. Cargo install is only for installing programs and can be used with libraries. To use a library, create add it as dependency to cargo project with cargo add. Yeah, I'm not sure what's going on now. Hello. Hello. Sorry, I just saw it. Cargo install bootloader. So post build. So I can't really install the bootloader. You need to have the LLVM tool preview rustup component install. You can do some executing rustup component. Looks like you're in a rusty. Yeah, that's no, I want to type and say that's well said. Why am I typing? That's well said. Yeah, in a rusty pickle. Yeah, but it was fun before because I was I'm trying to I almost complaining because I'm all this kind of code is go here, do that. But then I thought of a game for my 4-year-old. So how can we write the hello at like a buffer and pick a color and a letter? And that was so nice. Like I would never think of that by studying functional programming because, okay, I need to install this Rust up that was so nice. So I came up with this game. Default nightly is kind of spooky. Oh, is it? Yeah, I never program in Rust. I don't know Rust. I've only programmed a bit of Haskell and Nix. So I like for me Rust or C or like Python. That's very spooky. But I'm brave. Okay, Rust up component add LLVM tools. Will this thing work? Component. It's downloading. How is it? So Rustup component downloading. Yeah, it's downloading. I like the tutorial here. Okay, after installing boot image and adding, but for running. So this probably won't work. Oh yeah, this won't work. This is for running the boot image. I need this, not to install it. I have to see why this isn't working. I'm not sure if this has to do with the Rust that he's using is 2018 and I have 2021. I don't think most programs you compile are meant to use nightly, but hey, you bear responsibility, not me, low. Yeah, maybe it's the tutorial because it's using the 2018 version and I'm on 2021. Not sure if I'm, why am I typing to go down? Not sure if I'm supposed to go down. Cargo image, boot image. Yeah, if I do now cargo was this bootloader? No, it's not because it has no cargo install. It's only for installing programs and can be used. Is it normal? uBlock don't work for me on Chrome. Is it normal? I don't know. Hi, uBlock don't work. Yeah, I also use it on Firefox. I don't use Chrome though, but it should work. MV3? Oh, that's like, yeah, there was like uBlock and uBlock Lite. I don't know what's MV3. What's MV3? MV3. What's MV3? Extension Chrome for developers. What am I now looking? Extension manifest? Manifest V. Migrate your extension. What am I looking at? What is MV3? Is it bad? Chrome changed how extensions work. Oh, I didn't know that. Thanks. It can't block network requests like from MV2. Oh, that's cool. Wow. So what do I do here? Running boot. How do I go down to 2018 now? Maybe I should go down to 2018 nightly. Does that even make sense? There's nothing to install, and he said like, okay, if I go to code source, where is it? Rust source, Rust improv. Wait, to stop this. So if I go to improv's source main, where is it? Yeah. No, I'll use bat. Let's see. It's not 2002 we were browsing. Okay. Don't mangle the name of this function. So I don't know, how do I downgrade to 2018 nightly? Is that even possible? Yeah, I need to ask this. Is it even possible to downgrade from 2021 to 2018 nightly? Rust? Yeah, maybe I messed something up. I missed something. Yes, you can use an older version of the nightly toolchain, such as one for 2018. I don't think this will, by specifying the date when installing or setting up the nightly toolchain, install a specific nightly date. Well, I could do this. Set the specific nightly version as default, globally or per project. Yeah, on cargo toml. Yeah, I've just ChatGPT said this. But do I do these commands like override, or I could just set it in where's the toml? Wait, cargo toml. Oh, here. So I just changed to 5 to I just changed to 2018, and that's it. Bootloader. You think it will work? Just no. The theory compiler should support 2000. That's what I was thinking. I don't think this will work. I probably have to like rebuild something, right? I don't think that this will work. And why do I have to be outside of the directory? Like I have to go outside to my home and cargo install boot image. Oh, it's working. No, it's not. It's different. I thought it's working. Can't find crate for core. Rust C explain. Could not compile. Can't find crate for STD. Oh wait, because now I'm in home. Will it do I have to go back now? This is weird. CD code. Where is it? Rust impros. So if I do the same, no, I have to be outside. In theory, yeah, it's not broken anymore, I guess. But yeah, but now I have a new set of problems. Could not compile semver. Why is it using this semver? Memchar. Why the semver? Memchar boot image. Yeah, but why the semver parser? Note the impros may not be install help. Build fail, waiting for other jobs to finish. Can't find crate for STD. Can't find crate for core. Yeah, it's not but maybe if I look at the config toml, look at this. So he has core compiler built-ins, mem, blog, boot image runner, config toml. Yeah, is he adding this stuff later? No, he's not. Using cargo run to make it easier to run our kernel, we can set the runner. Oh, okay, that's what he's boot image runner target. That's what he added here. The target. This is for Kimu stuff, but this I have this right. Where do I see this toml cargo toml? No, that's the config tom. No, that's the config. Where's the config toml? Oh, that's in cargo config toml. Yeah, build std target. Oh, he doesn't have the target. That was the problem also. Yeah, it's building all the depths, but this is where he said before to put in the tutorial, right? And now he doesn't have this compiler built-in mem, compiler built-in core, build std target, unstable. I don't have anything under unstable. Yeah, I don't know if I add this and then build target. No, he just basically added this to unstable. Oh, these things are under unstable. Okay, hx. Wait, I'm gonna change this cargo config toml, and I'm just gonna forgot what's the in Helix. I'm gonna take and then like this and paste it in here. Yeah. Right. So I have a build like this and unstable and target. I'm going to add this later. And unstable core std features. I guess this makes no different the order. Okay, let's try like this. Cargo install boot image. Now it's building better. It's building now. Okay, that was the mistake. Yeah, I didn't write that. Use what he does now. It's a building. Yeah, maybe I wasn't. Yeah, I'm now on 218, but maybe it didn't work because of that thing. Because it was because I wrote the config was not written well and doesn't work. What's going on? I see red. Use of undeclared type string. Could not compile JSON. Why JSON? Use of let mutbuff JSON value. Yeah, the tutorial is really nice, but it's kind of not so, like, this part for me is okay. Kimu, booting in Kimu. We can now boot the what do you mean we can boot the disk image? How does this work? We can see the tool recompiles our kernel using cargo build, so it will automatically pick up any changes you make, which will take a while. Like all crate dependencies, it is only built once and then cached, so subsequent builds will be much faster. Boot image combines the bootloader and your kernel into a bootable disk image. So after executing the command, you should see a bootable disk image named boot image blog os, or in my case improvs, whatever, bin in your target debug, which I don't have. It's still compiling. Yeah. Wow, this is a lot of. This is royally outdated. Oh, oh, I see. But I see the repo has been updated in like in last month or so. But it's funny, like he didn't. Maybe he didn't update. Like this config toml is. Look at this, and everybody really recommends this. Like it's linked. Look at this, 16K stars almost. But 5 years ago, cargo lock, cargo toml, 9 months ago. Some things are really updated. Update data layout for LLVM 18. I did this. Wait, run cargo toml. Look at this, 9 months old package. Blog OS 01.2.18. It's all the same. Wow. This help. How do I go look at this? It's still compiling. Oh, it's still compiling. How do you go down with Kitty? I'm new with Kitty. I just want to go to the end. Oh, I see. Yeah. Yeah, I'm not sure what to do now. I guess I'll look online. And actually, there is a YouTube. I know what I could check. There is. I didn't want to check what he's doing, but there is this guy who did the dark reader is slowing down. No, I don't. Okay, I'll just. My computer is slow off. There is the Rust Build Your OS and on YouTube. So build OS, I don't know, Rust, build OS, Rust. And maybe I can look what he did because it's kind of, this is from when? 2 years ago. Minimal Rust, VGA text mode. Maybe it's this. Can't you check up to-date docs for bootloader?
I've gotten the freestanding Rust binary part done. I've got the...
Oh. Can't you check up-to-date docs for bootloader? Well, doesn't that come later? Like I guess, wait a second. I mean, what's the difference? Okay, bootloader and boot image. I guess we have to first create the image and then up-to-date docs. You're trying to install it. Well, I'm trying to compile it first, I guess. Not install it, right? Or is there any, I'm not sure. Yeah, I'm not sure what you mean by install it. What do you mean? What does that mean to you right now? What does that mean to you right now? Because when I do this if the bootloader doesn't install, then none of it works. But what's the difference between the bootloader and the boot image? I thought that we are trying to compile it. Install it in terms of cargo is like using Gentoo. Yeah, I had that long time ago. Like you put all those flags to install the thing. So you mean like I don't have some flags enabled? It's if the bootloader doesn't install, then, but I'm confused because some errors have detailed explanations. Fail to compile the boot. You see this like boot image. Isn't that different than the loader? Cargo. Boot image creates the ISO to use with QEMU. Yeah, that's what I thought. That's what I thought we were trying. And the QEMU will boot it, right? Maybe QEMU has the... Maybe let's see.
Kernel part done, and in fact, I put
I'll stop this also.
Each one of those as a separate step, and I did create. Let me see if I can pull this up here.
Freestanding
Just
Rust
drag it
button.
over here. There
What's
it is.
this music?
So I did create a
Okay.
repo for it. So we're going to keep that in.
Oh, that's him actually,
up
Phil.
on GitHub.
Yeah.
As we.
Are there any like? No, it's not. No. Oh, look at this. The volatile library. Only up to 20 minutes. Yeah, I don't know. Let's find it. It's the dependency tree that's imploding. The dependency of the boot image. Of the boot image. Cargo install boot image. Well, the boot image is the boot image. Look at this. You need to install to create a bootable disk image from the compiled kernel. You need to install the boot image. After installing, you can create the bootable disk image by running cargo boot image. This creates a bootable disk image that we will run now with Chemo. Cargo run. All right. But boot image is this thing. Boot image creates a bootable disk image from a Rust cargo installed boot image. First, you need to add a dependency on the bootloader crate. 09. Here is 098. 098. All right. Maybe we're onto something. 098 and ooh, that's gonna be cargo. Where was this config? Where did I write that? No, it was not here. HX code Rust Rust, and what was it?Mpros. Why is it not? I don't have completions. CD Rust, CD improv. Where is it? Cargo toml. Is it here? Yeah, okay. Okay, bootloader 0.9. Let's add 8. Maybe now it will work. Cargo install boot image. Maybe now it will work. Older docs is the dependency tree. Older docs. Yeah. Really, thanks for the help. This is really nice. I didn't think anyone will really watch this or not even stay so long. Okay, maybe it'll work now. So what did he do? Writing an OS writer. This is already far. No, writing it. I think now it's episode 2. No, yeah, we didn't come up to this part. This is an episode 2. Yeah, panic handler. Too bad there are no. Oh, Chemo. Okay. Let's see this. This will maybe work. Older docs. No, it's not working. Oh. Cannot find attribute. Red. Maybe let's do like this. He's reading now this. The multi-boot Rust nightly. Yeah, we did this. Linker, flavor, features. I think it's somewhere over here, could be. Compiler, cargo, Rust up component. What is he doing? Component, add Rust source. Okay, we did that. Rust up show. Stable, default. Toolchain nightly is not installed. The AI suggests solution like One, throw your baby into boiling water. what's what's the like throw your baby? Why boiling? That's so harsh. The AI. How did AI come to this? This is like I can't believe like ChatGPT would write something like that. Throw your baby into boiling water. Should I throw the bootloader and boil it? No, I don't mean. Trust is a non-issue. Active toolchain. Wait, I'm. It's gonna be here. Info. All right. Now it's gonna be here. Uh, channel nightly. All right. Compiling. What did he compile? Cargo build target. Wait. Cargo build target. That was actually the. I didn't build. Wait. Cargo build target. Maybe I have to build the JSON file again. Did I build that? Code Rust. Code Rust. CD in pros. This thing. Did I build? Cargo build. Cargo guild. Guild. Cargo build. I did this. Target. I think I did this. Now I'm not sure anymore. x86. Will it? Okay. Linux. No, not unknown. Npros. JSON. Yeah, it did build this, I think. Maybe it will just rebuild it. It will rebuild it. Cannot find type E8 in the scope. Mat EA. So, wait a second. Mat EA. Mat EA. For more information. But now maybe I'm rebuilding it. JSON toolchain nightly. Toolchain nightly. Wasn't expected. Yeah, but I don't. Toolchain. Oh. Toolchain. Yeah, I'm not sure what's going on now. Yeah, toolchain nightly. Is it toolchain? Toolchain. Unexpected. JSON after toolchain. So this does not even work? No. Really? No. Yeah, also. It isn't valid in this context. Typo in comment. You mean U8? Oh, it AE8. Oh. Yeah, yeah. Why would I? Yeah. Could be U8. Yeah, could be U8. But I was almost U. Wait a second. Oh, this is weird. Wait. U8. This is weird. It was just something weird with Helix. It's like I typed U, but it gave. No, it was a typo because it could be because in I do use a different layout, and the U in E is just under U on Workman layout. Yeah. Let's try again. Cargo build. Toolchain found. No, I'll just remove this toolchain thing. Now it works. Maybe if we do again cargo install boot image. Will it work? Maybe now it will work. You're not using the LSP? Yo, not yet. Maybe yeah, no, I'm not. I think I'm not, because I have to set it up. This is Helix. I've never actually programmed in Rust, so I still haven't, like if I go to, I think I go to like Helix Health, and there is Rust. Well, it has LLDB, and I have Rust Analyzer. Maybe I didn't set it like, not sure. We'll have to check that. So you're saying it's not working, my LSP? Yeah, it should show like red dots or something when something is wrong. Guess you're using Arch. Void at the moment. Yeah, I'm on Void. I don't know Void much. Actually, I was using NixOS for like many years, and I had a whole YouTube channel just around NixOS. I was putting a lot of NixOS content, and now suddenly I changed to Void just because I want a bit of change, and I'm doing Rust now, and it's a complete change. Your CPU is having a pretty rough yeah, I'm not sure how to handle that. I thought it's the camera, but like if I look at this, look, if I go to NeoFetch, look at this. This shouldn't be so slow. Do I have NeoFetch? Will NeoFetch show? Yeah, look at this. I have i5 86. It shouldn't be that bad. It shouldn't be that bad, but maybe because someone, we stepped on the laptop, and the sound has been a bit off and everything. Maybe it's like, I don't know. My idea, it's a Zen book. It's an old Zen book from. My bone with Nixos is to try to make perfection out of an imperfect supply chain. Oh, but Nixo is so nice where you can just declare the stuff what you want. That's so nice. They have so many good things, with Nixos. But it's true, sometimes it really takes a while. It just takes a while. And now it was so nice when I installed Void Linux. It was very cute in a sense because I installed Slackware 2009. That's the first time I installed Slackware. 2008 I installed Slackware on a laptop. It was, what was it? I don't remember. And the vibe was like when I installed the Slackware, all these menus, and then I had Arch Linux. So it kind of Void kind of reminded me a bit. It's like Slackware but with a package manager. And I've been on NixOS for like last 4 or 5 years. So now it's like it's almost like going back to the past, So it's a good thing you're simply adding a user-friendly abstraction on an already niche distribution. It's a good thing you're simply adding a user-friendly abstraction. Oh, what do you mean? Wait a second. What do you mean? A user-friendly abstraction? Yeah, I'm not sure what you mean by this. Can you explain? Some errors have detailed explanations. Yeah, give me a detailed explanation. EO405 could not compile. Oh, this is gonna take a while. This is gonna take a while. Let's see what he did. Source mangle. Process exited.
Address OXB8000. And then each character cell consists of an ASCII byte and a color byte. Implementation looks like this. Okay. So we're
Oh,
going to
with
do another
NVIDIA.
no mangle.
Oh, I didn't
have to
have
start.
NVIDIA, yeah.
Let VGA buffer
Sorry to hear that.
equal to hex B8000 as star mu8.
Oh, but yeah, I do know they having this. I was when anything happens outside of the NICs where the whole system collapses. Well, it's kind of hard. Like I remember, like the first I was involved with someone from the CUDA team in NixOS, and they have this whole team that kind of packages PyTorch and all of these things that are built with Python, and it's such a huge mess. It's like everybody's working so much and arranging the packages, and at the beginning I had no idea what everything means. It's like the simple rollback freedom thing doesn't work when your hardware doesn't roll back. Yeah, I didn't have that experience when your hardware doesn't roll back. Yeah, but I think those are some of the really great things. I guess you can do that with tools, you can do that with tools. But the thing with tools like Ansible or like Puppet or something, it still changes the state. It changes the state. So with Nix, you kind of change it like, and I like the Nix store idea, right? You have a Nix store. I mean, when you just talk about it, it's really simple. You have a Nix store, and each program is a hash. It's a hash, like it's there as a hash, and you can have many of them. It's in one sense you think why isn't like that by default, but we have all these files like folders, or so it gets things. It's kind of, I like this abstraction of the Nix store, but I guess you have to have good tools for it. I guess the tools, but they're working hard. Software wise it's great, but compatibility is not good. Really like the Nix packages. Yeah, they really, I like them too. I was yeah. Recently I made a video of my first like Nix, making a first Nix package, and it was this some kind of a webcam kind of a thing, and it took me really long to get all this straight. And the great thing about them is that you can really contribute over the GitHub. They're really on GitHub, so you can upload, you can maintain your package. It's not so closed. The vibe is really wide, so you can really, yeah. Anyway, now I'm talking about NixOS and Nix, or it feels that way. Tools are good. Documentations, like you have to try to find 15-year-old research papers. Yeah, you have to know, but they're like sites like the great sites are like, you go to NixOS options, and you go to options search. And here you can search for options, like you go X server, and then you can see stuff which you can look at this services X server, variant. Look at this. So string, and so this means you write services X xkb this, and then you write your keyboard layout, and you put that in configuration.nix. So this is a nice way to how to search. So not just packages, but also this NixOS options and the modules. That's like the best part with NixOS. Everything's defined like this, which I was looking. This is same with Rust and with the colon. So Nix, instead of the colon, has a dot. So that's like what I did with the cargo. No, with this main RS. It has like colon, like a word and a colon and a word. So that's like that's the modules. That's really cool. Yeah. Anyway, writing an OS.
4i byte.
Okay, so search is great.
Oh, I gotta put the static here. Static. Hello. There's an array of U8s.
But I like really, functional programming.
That looks
and
good.
I'm really bad at this. I don't get this.
Iter.
You have to write all these kind of
unsafe
codes.
Ooh, unsafe. VGA buffer offset I as I size
really knows
times
this.
2
Size
equals
times
byte. VGA buffer offset I as I size times 2 plus 1 is equal to OXB. I assume this is the color bit. And then we want to, well, we still want
he
to
wrote ooh. Yeah.
at the end of that. Okay.
Do I have this all also? So Rust and pros. Main. So panic handler. I still have this static panic handler, panic info, no std, no main, use core panic info, static hello. Static hello. U8 be hello world. Like, what's the be hello? Okay. No mangle. Pub extern C function start with empty. This is let VGA buffer as mut U8 for I byte. Yeah, in hello iteration enumerate unsafe. Unsafe. VGA buffer I as I size. I as I size. +1. Yeah. OX 0xb byte. And loop. All right.
First, we cast the integer b8000 into a raw pointer. Then we iterate over the bytes of the static hello byte string. We use the enumerate method to additionally get the running variable I in the body of the for loop. We use the offset method to write the string byte and the corresponding color byte.
Yeah, I'm sure. No,
B
this
is
is
light
really
cyan.
the hard way.
Too far. Note that there's an unsafe block all around memory
Well,
bytes.
at least
The reason is that the
him.
Rust compiler can't prove that the raw pointers we create are valid. They could point anywhere and lead to data corruption. By putting them into an unsafe block, we're basically telling the compiler that we're absolutely sure that the operations are valid. Note that an unsafe block doesn't turn off Rust's safety checks. It only allows you to do 5 additional things. And we'll take a look at those later. I want to emphasize that this is not the way we want to do things in Rust. It's very easy to mess up when working with raw pointers inside unsafe blocks. For example, we could easily write beyond the buffer's end if we're not careful. So we want to,
do you like when you watch these things to have these lo-fi stuff behind the music?
To minimize the use of unsafe as much as possible. Rust gives us the ability to do this by creating.
I have no clue about Rust. No, I have no clue. Like, I haven't. I mean, I read about it. You know, I read here and there. You know, I saw the code a bit,
safe
but
abstractions.
I
For example, we could create
a bit. You know, and no, not really. No.
VGA buffer type that encapsulates all unsafety and ensures it's impossible to do anything wrong from the outside.
Like, I can see there is a for loop here. There is a for loop here, and they are from functional programming. I can see like this fn, for example, there is a function, and the function, I can see this like a types like a and b, like did you use like where you have a function, right? And from a type to B type. Are you trying to learn Rust by making an OS? Maybe, you know, I don't know. Yeah, because if I would go with a book, I tried like to go with a book. It's just maybe not so fun. Like, I don't know. I thought like this will be great because I would never work on something like this. So why not do both? Learn Rust and build an OS. And
this
also there was one thing. Okay.
Only need minimal amounts of unsafe.
I was applying for the Summer of Nix. Read the Rust book first. Rust by example has you make a server. Yeah, I know those books. you know what? I should read it. I tried to apply for the Summer of Nix and Google Code for Nixos, and one of the projects was working on Nix, and Nix is written in C++, and I never, a lot of the people that even work with Nix don't really work with Nix itself, and there is this small team, good team, I mean, there is a small team that work with Nix, and it's all C++, and now also one of the one of the projects was writing Nix for Windows. which is really cool. So you wouldn't need WSL or something. You would basically natively have Nix on Windows. Oh, I just got a message. Temos lika ventila, temos lika. Si uspije pobacati. Oh, I should do something. Ne, još sad ću počet. I have to stop the stream. We have to clean. We have to renovate our kitchen. And I have to stop the stream and I have to just arrange. But really, thank you guys. Thank you for really coming. This was really nice. This was really nice. I really like Twitch about this. It was really nice. Thanks. Please read the Rust book first. Rust by example as you make a server. All right. I'll say that. All right. Thank you so much. And I think I'll close this. And I have to fix stuff, renovate my. We have to renovate our kitchen. All right. So I'm gonna stop the stream and bye bye. Thank you so much. And see you. Yeah. Thanks so much for the advices. Bye bye.